This video is going to talk about the power rule. The power rule is what we use for basic derivatives of functions. Now the basic equation for the power rule is d dx of x to the n equals n to the x to the power of n minus 1. The power rule is valid for all exponents n of a single non-exponential function. This includes negative exponents, fractional exponents, irrational exponents, and positive exponents. This rule applies only to power functions with no variable in the exponent. Derivatives of exponential functions are calculated using a different formula that we will have to learn later in the course. So now that we know the basics of it, let's try some examples. First, let's try some with positive exponents. So if we had the equation y equals x squared, and we want to take the derivative of that, we looked back to the base equation of y equals x to the n. The derivative of this is y equals xn equals nx n minus 1. So we take this and apply this to y equals x squared. So we go y prime would then equal 2x and n minus 1, which would be 2 minus 1 to the 1, which just cancels out to become negative x. So that one was pretty basic, but now we can try a more in-depth one. So if we had the equation y equals 4x to the 5 plus 3x squared plus 7x plus 1, we could then apply this rule again to all of the separate parts of the question. So the first part, we would take 5 down, and 4 times 5 is 20, which would be your n value, and 5 minus 1 is 4. So you get 20x to the 4 plus, then for the second one you take 2 down, 6x, and 2 minus 1 is 1, so it's 6x to the 1, plus, if the original is 7x, you take 7 times the 1 that's in the exponent to give you 7, and 1 minus 1 gives you 0, so the x will then disappear. But now, when you have just the regular number at the end of it here, plus 1, there's no x value at the end of it. So that's just going to turn into a 0. So your derivative of this long function here just turns into 20x to the 4 plus 6x plus 7 plus 0, which in the end will just cancel out. So now that we have the basics of positive exponents, let's try some with negative exponents. Now with negative exponents, all the same rules apply. So if we had the equation y equals x to the negative 1, we still use the same equation of y equals x to the n, and y prime would equal n x to the n minus 1. So we take the same steps as before. Take the negative 1 and drop it out in front, so you get negative x, and you go negative 1 minus 1 to give you negative 2. So now that we have the basics of that one down, let's go ahead and try a more complicated one. If we had the equation y equals 4x to the negative 3 plus 7x to the negative 2 plus 14x to the negative 1, we would do the exact same steps. We would take 4 times negative 3 gives us negative 12, and negative 3 minus 1 gives you negative 4. Next one would be plus 7x to the negative 2. If you take the negative 2 and multiply it by the 7, it turns into negative 14. So it's minus 14x to the power of negative 2 minus 1 gives you negative 3. And then the last part is plus 14x to the negative 1, which you bring the negative, multiply 14 by negative 1, gives you minus 14x, and negative 1 minus 1 gives you to the negative 2. That is the basics of it for positive and negative exponents. And now let's try some with fractional exponents. So with fractional exponents, it is again the exact same steps. If you had y equals x to the 1/2, you would start by bringing the 1/2 out to the front, so you get 1/2 x, and then 1/2 minus 1 is just negative 1/2. So you get 1/2 x to the negative 1/2. This is the same steps if you had the equation y equals x to the 3 over 2. The derivative of this would be 3 over 2 x, and then 3 over 2 minus 1 gives you 1/2. So you get 3 over 2 x to the 1/2. Now that we have this, let's try one with a coefficient in front. So if you had y equals 2x to the 1/2, you do the exact same steps. You bring the 1/2 down, so you get 2 times 1/2 x, and 1/2 minus 1 is -1/2. But now you can combine these two front terms. So 2 times 1/2 just gives you 1. So your final answer would then be x to the -1/2.